Hello everyone, I'm Devi, I'm Dr.M.Devi, Assistant Professor, Department of Mathematics, Deakin College, Fatima, Vellore. So in this video lecture, we are going to see about some basic concepts of graph theory. So first let us see what is graph. So everyone know about the structure of graph theory. This is G equal to V comma E. Here G is a graph, V indicates the set of vertices, E indicates the set of edges. So this is the example for simple graph. Named the graph as A, B, C, D, E and F. So in this graph, the set of V equal to the set of vertices, which is A, B, C, D, E and F. E equal to set of edges. So in this graph, we are having 8 edges: AB, AC, BC, BD, CE, DE, DF and EF. So we are having 8 edges. Everyone know the real life application of graph theory. So the best example is friendship. Okay, so in this graph, consider the A, B, C, D, E, F. Consider all the vertices as a person. This H indicates that A and B, that is the person A and B are direct friends. Okay. In the same example, the person A and F. A and F both are not direct friends because there is no direct edge between A and F. The other best example is road. Suppose A, B, C, D, E, F, all the vertices are considered as a city, which means the city A and B have a direct road between them. In a similar way, the road A and F cannot have a direct road between them. So in the graph, we can give the values of edges also. Suppose the distance between A and B is 10 kilometers, which means that the distance between city A and the city B is 10 kilometers. So the value of the edge is also known as the weight of an edge. Weight of an edge. Okay. So the next one is order of a graph. So order of a graph is the number of vertices in a graph. So in this graph, the number of vertices is 6. So it is written as cardinality of V equal to 6. And next one is size of a graph. So size of a graph is the number of edges in a graph. So here number of edges, that is cardinality of V equal to 8. So this is the size of a graph. Okay. Next we are going to see about the types of graphs. There are basically 3 types of graphs. So one is undirected graph. So this is the one example for undirected graph. The vertices are A, B, C, D and E. Okay, so the basic condition is if x, y, then y, x. That is, in undirected graph, there exists edge between A and B, then there exists edge between B and A. Facebook friendship is the best example of undirected graph. So in the Facebook, A is a friend of B, then also B is a friend of A. So this is undirected graph. Second one is directed graph. So directed graph, so in the same graph, we give a direction. Okay, this is the directed graph. So in this graph, suppose the basic condition is if x comma y, then does not mean y comma x. That is, there exists a edge between A and B, then it does not mean that there is edge between B to A. Okay. Twitter friendship is the best example for directed graph. So in a Twitter, suppose A is a friend of B. Okay, but not enough that B is a friend of A. This is the example for directed graph. The third one is mixed graph. So mixed graph. So the same example. So mixed graph consists of both directed and undirected graph. Okay. So in a mixed graph, so consider this edge AB. So in the AB, there is no direction. That is, suppose consider an example. The vertices A, B, C, D, E are considered as a job. Okay. So A and B both are independent for undirected graph. Suppose A can the job A can be done at any time, job B can be done at any time. But for the edge B to C, this is a directed graph. If after the completion of B only, C can start the work. So that is the outcome of B is the input of C. So this is the types of graphs. Okay, next. So classes of graphs. Okay, the first one is regular graph. So regular graph and simple example for regular graph. So in a regular graph, all the vertices have the same degree. So in this graph, all the vertices has degree 2. So this is 2 regular graph. Suppose if all the vertices have degree 3 means the graph is 3 regular graph. In general, all the vertices have degree k means which is called as k regular graph. And the second one is complete graph. So this is the simple example for complete graph. So complete graph. So complete graph means all the vertices, that is every vertex in a graph having adjacent to all the other vertices. For example, if A is the vertex, then the other vertices B, C, D, all the vertices are adjacent. That is, all the vertices are connected to every vertex. This is called as a complete graph. Third one is planar graph. So this is the example for planar graph. So in a planar graph, no two edges should intersect. That is, this is the simple example for planar graph. This is an example for non-planar graph. So in this graph, two edges are intersect. Okay. Suppose if you want to make this non-planar graph as a planar graph, we can draw in this way. This is planar graph. Next one is connected graph. So connected graph. So suppose if you take two simple graph. So the vertex A and F. There is no path between the vertex A and F. Suppose if you want to connect this, you can draw an edge between these two vertices named as A to C. Then there is just a path between the vertices A and F. So this is called as a connected graph. Thank you for your listening.